Hey everyone, welcome to 2026 and a new episode of the SaaS Sessions podcast. Today we have Catherine Johnson on the show with us. She's the VP of Global Solutions Engineering at Hydrolix. Hydrolix, if you are not aware, it's a real time data platform that solves what the industry said was impossible, which is sub-second analytics at really true and massive global scale. Right. So I think Hydrolix was founded to solve one problem, like how do you deliver real-time insights on terabytes to petabytes of log data without choosing cost or performance, right? Like that's what Hydraulics does. And Catherine's been leading the solution engineering team at there. So hey Catherine, such a pleasure to have you on the show.
Thanks. Nice to be here.
Great. So, Catherine, I gave a very short intro and my understanding of hydraulics. I know it's still a very technical product for me, but maybe you can, explain more about your role and your journey so far in the SaaS and the solutions engineering world, and also about hydraulics. Maybe not like ELI 5, like explain it like I'm 5, but in
Yep.
maybe much more simpler terms.
Yeah. So I have been in data my whole career. And around 2015, 2016, I got more into observability data.
Mm.
And that I was at Elastic at that time. And basically, what we were seeing was such a growth in people using Elasticsearch for observability data. Um, but not like at that time, Elastic wasn't really built for that. Like there weren't out of the box dashboards and things like that. But what we saw was this tremendous growth. And so even as early as 2017, 2018, we were seeing customers that would have hundreds of terabytes of data a day, and they would want to keep it for, 12, 15, sometimes 7 months, sometimes 7 years. And so that was very much on the application side of things. I worked at a few different observability companies. In 2019, I came to Hydrolix. So the company was founded right around the end of 2018, beginning of 2019. And when the CEO initially approached me, he was like, "Hey, we've got this solution where you can ingest like terabytes and petabytes of data and keep it in object storage and still have reasonable query performance." And I was like, "Right, sure. Like that doesn't exist. Tell me how that goes because I haven't seen it." But the background of the founders of Hydraulics came from the CDN world.
Mm,
So CDN logs, especially for like media streaming companies, are just magnitudes of order larger than like application observability data because it's every single request is getting logged. And they had already been through at a prior startup, Sedexus, trying to deal with CDN logs. And they had tried everything. Like they had tried all of the available solutions on the market. And they were always either, it was expensive, they were sacrificing performance, or they were throwing away data.
mm,
And so the goal was how do they go about, or how do we go about creating a platform where you don't have to make those trade-offs? And so we built from scratch using cloud first technology. So like we need object storage, we need Kubernetes. And by leveraging modern paradigms of application development was really how we got there. And we also did quite a bit of work around compression and how we store and access that data in object storage to make it performant. Because one of the first things people say is like object storage isn't performant. You can make it performant. You just have to use it the right ways. Came here in 2019. I left briefly, when did a couple of my own startups, and then I came back in 2023 to do more solutions engineering type of work. At that time, we had a team globally that did solutions engineering, SRE, services, support, everything,
mm,
all as one group. And early on, there were only 6 of us globally that were doing that work. And so everyone was on call because we run it as a SaaS platform.
mm.
And over time, these teams have grown because we've grown our customer base to over 600. And so we've been like specializing these teams more as we've grown. So in the past summer, we started the solutions engineering team as a dedicated function to work with customers that are either potentially new customers or customers that are trying to attack new projects.
Nice, nice. I think that's been a very interesting journey, right? Like solution engineering, like as a whole function, I've not seen like a lot of companies like spend a lot of time and interest and efforts like building into, right? But for you, I think that's the core part, right? And I think earlier in our conversation, you were mentioning that you were literally in the room during the Super Bowl 2025 broadcast, right? Like managing like terabytes of data in real time, right? And was like the field CTO as well. So for context for everyone listening, I think that's I think you mentioned like you guys processed about 1.4 petabytes of data per day or something like that. And I want to know like what was that experience like, and what sort of things that surprised you the most about what happened?
Yeah, sure. So at that time, like you mentioned, I was a field CTO, which meant very deeply hands-on. Like
Mm,
our field CTOs are the experts in our product, they're the experts in data. And so we had started working with Fox, who did the
mm,
Super Bowl in 2025 in the summer ahead of the Super Bowl. So as football season starts, their traffic would ramp up quite a bit. So it's very
mm,
specifically with Fox Sports at that time.
mm,
And so they wanted to bring together data from a bunch of different CDNs because no one CDN had the capacity to broadcast the whole thing. And like there's regional differences with CDNs. And so they wanted to be able to route traffic based on performance or based on errors or just volume of traffic as well. So we started working with them summer before on the data. So
mm.
very specifically like what's the data architecture that we need to answer the questions that they needed answered at scale? Because anything when you're talking about small scale is pretty easy and straightforward to query. You're not like super worried about storage or any of that because there's plenty of compute now. So for us to get to dial that in to get the performance that they needed, we had to really think through the data architectures. For us, we can have multiple schemas on a single table.
Mm,
So what we decided on was all CDNs were putting the data into a single table and we normalized that data. And that didn't just mean like finding field names that were in common. It was do the units match? You know, this one sends something in seconds and it's a decimal, and this one sends it in milliseconds and it's an integer. And so going through all of those things, and each
mm.
of the CDNs has different specialties. So they all send different data depending on their specialty as well. So there's some things that just don't translate. So we kept that data so that they could dive into it, but we took common things like HTTP status codes, time to first byte, time to last byte, number of requests, and put that into a table and got the data correct. And it wasn't just the schema, it was really also like some fields are URL encoded. Some fields have been URL encoded multiple times. So like it's just like this, turtles all the way down kind of thing where you have to decide like at what level do I stop?
Right.
So we got the data correct. The next thing was testing. And
Mm,
testing, I think everybody knows testing at scale with a representative data set is very challenging. So you can create a data set, but it's not going to look like your real traffic. So as the season went, they would have games, and as the American football season progresses, more and more people are watching games. So
mm,
early in the season, you don't have as much traffic. So we had some validation early on that like we've got the data right, we have everything scaled appropriately, our object storage is performing as we want it to. And then as the season went on, um, the two big tests for us were there were two playoff games
mm,
that Fox Sports was going to broadcast. And in the first playoff game, we had amazing performance. Everything worked as expected. We were super happy. There were no hiccups. We had our SREs on call. I was on with like all the vendors were on with Fox Sports during the game to make sure everything was going well.
Hmm.
In the second playoff game, the paths changed, like the request path of the data was very different than what we had observed in the first playoff game.
Hmm.
And because of what they were querying, it had a really bad, not bad, big impact on query performance. And
Hmm.
so after that game, we had to step back and look at our data architecture again and say, okay, given this constraint where pretty much every single request path was unique, given that constraint, how do we do the data architecture so that queries perform? And so it wasn't a complete redo, but we had to go back through and say, okay, well, what are the parts of the path that are really important to query quickly to make sure that all of those things were in a format that you could do them quickly? Because at scale, when you're talking about a petabyte of data a day, regular expressions, like doing
Hmm.
regular expression matching is computationally intensive,
Hmm.
right? So at that scale, what you're trying to do is like how do you make sure that the important queries, you can still do regular expression matching, but the things that you want back quickly are indexed with exact matches so that you're not having to do that at scale, because what you can end up with is like a massive table scan. And when you're talking about petabytes, hundreds of terabytes of data, that's a lot of compute and memory that would need to be available to do that. So we backed up. We made sure that that was all right. We also made sure that we needed to make sure that the data matched what the CDN vendors believe that they were sending to us,
Hmm.
because we how do you prove that you got all of the data or the right amount of data? And sometimes things show up late. Like we have one of the CDNs can send data hours after the fact.
Hmm.
So like we had to go through this whole process of like how do we validate that it's accurate and correct? And some of the log vendors don't even guarantee that they will send all of the logs. Like if you go into CloudFront in AWS, there's a big disclaimer that says they don't guarantee 100% delivery of
Hmm.
logs. And so there is sort of this back and forth around like how, like, what's the time period where we can look at like the source and what we received and make sure that it matched? So like,
Hmm.
do we go back an hour? Do we go back 2 hours? And then also, what's the amount of error that we are okay with, given that there isn't guaranteed delivery of the data that we were receiving? So we got through all of that. The day, well, I guess before Super Bowl, what we used those two games for as well, not just for data, was to validate the cluster scaling and
Hmm.
understand, because that we couldn't, neither of those games were scaling to Super Bowl level. So we
Hmm.
had to extrapolate like how much compute did we need to process that data and then figure out like what do we think we need for Super Bowl. And they didn't have a number of like we will have 20 million viewers. It was like we could have between, I don't remember the exact numbers, but like 10 and 50 million viewers. And it just really depends on like who's playing, what's the, are the teams well matched? Did something really interesting happen during the game? Because that, like,
Hmm.
if towards the end of the game, if it was getting boring and then suddenly there was like something exciting happen, then you would see viewership go back up. So we had to be prepared for, we were actually prepared for 3x the traffic that we received
Hmm.
just in case. But what we realized in doing that was we were running this in AWS. The compute needed to run for Super Bowl was not going to be available in a single AWS region.
Hmm.
So we had to, and we were already architected to do this. But we have to design it and make it work and test it, right? We ended up doing a multi-region deployment so that we could have all the compute needed.
Hmm.
Um, day of, the we did, I guess, a couple days before we we were all together, everyone who was supporting Super Bowl, and we did a couple of dry runs. And so they were causing failures in the system, making sure that we were catching all the data, that we were seeing the failures, that the playbooks that they had come up with for different things that could go wrong worked. And like that was the right process. We didn't need to make any modifications. And then day of, we brought everything up very early. We scaled to the peak ahead of time because at this scale, like auto scaling is great, but it's not something for critical events that you want to necessarily depend on. So
Mm,
we went ahead and scaled up as much as we thought we were going to need. So it was available rather than depend on that. Our product does auto scale, but again, like in a critical event where you're like this must work, like you don't want to be dependent on that. So we brought everything up. As the day went on, we saw more and more traffic coming in. We saw the viewership going up, and we had our SRE team was I was actually on a Zoom meeting with them the entire day, just making sure, like monitoring live, which
mm,
typically an SRE team isn't watching dashboards, right? But we were watching the dashboards because we wanted to know before, like
mm,
we wanted to see trend lines and make sure that things were going the right way. So during the game, we ingested 200 terabytes of data in just a few hours. That added up to like if it was that level all day, it would have been 1.4 petabytes for the
mm.
day in total. But it was just like during the game time. And we had 5,000 queries or somewhere around there was what were executed during the game. And the average response time was half a second.
Yeah.
And those queries were mostly dashboard queries. So we had an executive dashboard where leadership at Fox Sports was watching what was happening. They were making sure that like the traffic wasn't going over any contractual agreements. And then we also had individual CDN dashboards. So if there was a problem with a specific CDN, we could look into that. And then we also were doing ad hoc queries as well. So there was something that came up during the game. They're like, why is this thing getting for? We don't understand why there's a 404 here. And so there were live queries we were doing that were effectively like analytics queries trying to figure out what the problem was. It was on a very specific CDN.
Mm,
And so the way that we achieved that half a second was those three things, the execs, the individual CDN dashboards, and the ad hoc queries. We had three distinct sets of query compute for those, all going against the same data sitting in object storage. So they didn't compete with each other. So you didn't
mm,
have like, I was running some of the ad hoc queries that wasn't competing with compute for what the executive we're
mm,
looking at. So again, like lots of preparation, everything's scaled up as much as we thought we needed, which was great. We didn't have to worry about like, is something going to come up or not come up? Everything was already running. And then, yeah, just the most of my role of being on site was if like they wanted to know anything different than what we had architected for, like what comes up during the game.
mm,
And they had me in the room dedicated because I knew the data really well at that point to like going in and figuring out like, okay, how do we query this in a way that we're going to get answers back quickly? Um, yeah, it was tons of preparation, but you can't for an event like that you can't actually test
mm.
because it's a scale that and variety of data that you can't reproduce or imitate.
Nice. I think it would have been like one hell of a war room, right? Like for you and a team to be in and like, just being prepared for anything and that comes across, right? Like sounds very interesting, but also very like, high intensity and high pressure environment, right? Like where you have to be ready, like, for half second also, right? Like you cannot like look away from the screen or and not be available, right? Like must be very high intensity, as I said. So so managing these kind of events, right? Like whether it's Super Bowl, whether it's like some, I know like you have a lot of customers like e-commerce during like Black Friday sale and during let's say Halloween or holiday season, right? So even half a second makes or breaks, the trust of a customer, right? Like whether it's like even one of their end customers faces a challenge that kind of raises a lot of questions for your customers, and then in turn to your team as well, right? So being accurate is not it's a must have, right? It's not like a good to have anymore, it's a must have. Like you cannot afford to be 99% correct, right? Like you have to be 100% all the time. So in such situations, right? So how does your team act or deal with these kind of scenarios differently, right? Whereas these high intensity, high pressure environments or events like like the Super Bowl or the sale, right? So what's your engineering magic? Like, do you have a playbook that you have built internally, to manage or handle these kind of events? Or would love to know if you can share that.
Yeah, so it's for us, we call them high traffic events. Sometimes they're scheduled, like Super Bowl, right?
Mm,
There's a date, you know that it's happening. A lot of our customers are streaming media companies, but sometimes we have some news companies and we have a customer that does weather. They don't know, right? Something happens and then suddenly they have a ton of traffic. So for the planned event, for Super Bowl, I said we didn't auto scale, but we do. We do support auto scaling. So when we have a planned event, we kind of go through the process that I was talking about, making sure that we understand how they want to use the data, what's really important to them. But for anything that's unexpected, we have SRE team has a ton of alerts, and we also auto scale.
mm,
So when we see traffic start to creep up, we have separate, all of our components are stateless and independent. So
mm,
like we have ingest and ingest pools. I mentioned query pools where we have different query types going against different compute. We same thing with intake as well. So we can have different intake streams. But as we see traffic come up, we have a scaling process that will see that the traffic is increasing. We run in Kubernetes, so nodes will be spun up in the back end. And then our intake can spin up because it's stateless pretty immediately as soon as the
mm,
compute is available. So that's actually an interesting point is the larger the instance types you use in your cluster, the longer they take to come up. So there's this balance of like an instance type size that will come up quickly so that intake or intake pools can come up quickly. So that's sort of on the intake side. In we have a background process that is doing we don't compress the data once, we sort of like continue to recombine things to optimize. And so that process also scales when intake scales because we need that to make the query really performant. The thing that we don't scale automatically is query though. We have a range. So like we'll say, we need between 5 and 20 instances of query available in order to support a customer. But we don't for intake, we want it to just scale as
mm,
much as it needs to because like we need all the data. Like if it's a DDoS attack, you don't want to drop any of the data. You need all of it available. But one bad query can spin up tons and tons of query compute. So
mm,
we tend to keep that like locked into a range that makes sense for a customer. Like we typically know how much they're doing. So a lot of times with high traffic events, we don't have to do anything just because of the way that the system scales and how we've architected things. We don't just do Super Bowl, we do other global sporting events similarly. And so for those, like, as much as a customer can tell us ahead of time, that's great. But the way the system's architected, we don't necessarily have to know that ahead of time.
nice, nice. And I think, Catherine, you mentioned like during the Super Bowl, right? Like the most valuable thing your team did wasn't really only technical troubleshooting all the time, but it was making sure that the Fox execs, right, like had a dashboard that showed everything is fine,
Yep.
and especially in a language that they understand, because not everybody might not be like always technical. So which means that the solution engineering team, right, like need to master things beyond the technical solutions role, right? Like you have to deal with like customers and weird questions. You never know what's something that they might ask, right? So what are some of the non-obvious skills that you feel are required for somebody in this role, right? Especially again, as I said, like it's very high intensity and high pressure, and you have to be prepared for something you cannot prepare for, and
Mm,
it's a very tricky situation to be in, right? So not only technical understanding, but I think there's a lot of decisions I'm guessing that have to be made, and those might have been like like a 10-second decision, like you have to decide quickly, otherwise something is going to go wrong, or you don't
right,
know if after the decision it's going to go wrong or not, right? So it's not only
right.
the technical understanding, but you also need to know the business understanding on what, like this decisions or these things impacts, right? Like your customer's business. So yeah, like what are these skills, like non-obvious skills, that you feel like anybody in solutions engineering should have?
I think a big one is building trust with
Mm,
your customer. So they have to feel like you know what you're talking about and that you understand them. So if you define empathy as accurate and correct understanding, like somebody feels heard and understood by you, I think that's a really, really big one. The second one that I think is technical people, we tend to jump to answers really quickly. Somebody will say like, "How do I do this?" And we're like that. Well, like we just answer it.
mm,
But for us or anyone who's working with data, like a customer can come to us and say, "How do I optimize this query? Like this isn't working well or something." That query may not be the answer to the question that they're really asking. So there's
mm,
this moment of needing to pause and ask in a way that the customer feels comfortable with. Explain to me what question you're trying to answer with this query.
mm,
Because our product is very technical. We're typically dealing with very technical people who are very smart, have a ton of experience. And so having that trust to get them to pause for a second and say, tell me what you're trying to get at, because the query that they decided on may or may not be the right question or the right answer,
mm,
right? It's so you really like having the confidence to also pause and ask that question. Because again, as technical people, I think we jump to answers really quickly. Like
mm.
I'm saying this, but I still do it.
Yeah.
Like somebody recently was like, "Oh, my query's not working. I made it with Chat GPT," and I'm like in there, looking at how to optimize their query, and then I'm like, "Hold on a second. What are you trying to do? Like, what is it that you're trying to answer here?" And then, it was actually a much simpler query than what Chat GPT had come up with. I think that's a really big one is understanding the why of what somebody's trying to do. And even like asking for specific features when we're
Mm,
talking to prospect. They're like, "Do you support time travel in a database?" Is an example, like where you can just go back to a checkpoint. We don't do that. We don't have a feature called time travel, but because we're a time series database, we can query what the data looked like at a point in time. So it's again backing into let's talk about what does time travel mean to you,
mm,
right? What's important to your business about this? Sometimes people just ask the question when you're like, well, why? Let's talk about what business requirement that fulfills. It's like, oh, I was just curious.
mm,
So it isn't like a real requirement, or it may not be top. So,
mm,
like, especially with really complex customers saying, okay, let's talk about the things that are most critical to your business operations. And then you have a better idea of like, what are the things here that are important, but not business critical? And so a really good solution engineer can effectively draw a map between like the very top is a business outcome. And below the business outcome, you're going to have business requirements. And
mm,
then every technical requirement should map to a business requirement. So having that understanding so that if, something comes up and customers like, what about this thing? It's
mm,
over here. We haven't talked about it at all. You can go back and say, okay, let's talk about and ask the question, how does that align to your business requirements? Let's discuss that. Because it's important, like anything you add, anything you do is always adding complexity, period, right? Every little thing that you add. So we're trying to make the solution as not complex for the customer as possible.
Mm,
And pull things together that are similar. But again, it's really like, how do I map to the business outcome that the customer is looking for? And that, again, that just it requires the trust to have the conversation. So I've even gone into customers. This was years ago, but I did a proof of concept with a customer who was a farming company. You're talking about video or e-commerce or banking or trains or airlines. Like, all of us as consumers have a frame of reference as to what that means. Like, I get, if I'm riding on a plane, I need a ticket, there's all this processing. I had
mm,
no idea how farms work. It just wasn't something I'd ever been exposed to. And so I started with, like, how does your business make money? Is that it was complex from both the
mm,
vendor and the consumer side. Where does the revenue come from for a farming business? And so just it didn't have to be a long conversation, but understanding at that level helps you then understand, like, what systems are important to them. And then, like,
mm,
okay, if those systems are important, then it's really important that we monitor those systems. And then also understanding, like, okay, well, they said this system's really important, but there's an identity management piece of this that they didn't discuss. So, if the identity management part goes down, like, then this, so you have to sort of think through all of the linkages as well.
mm. Interesting. And I'm assuming like most of these conversations would go like, with your customers, right? Like would go as you have planned, right? But I'm assuming that in some cases that, like the solution that you and your team have tried to offer may or may not meet the expectation of the customer, right? And
Mhm.
it couldn't solve the problem the way they wanted, right? And that sort of creates like a messy situation sometimes, right? So in your experience, like has that happened ever? And like if yes, like
Yeah.
how did you?
Yeah, of course. It we try to only work on opportunities where we know we can hit those requirements. So we start
Mm,
there with, like, for us, we're looking at, like, sort of their query patterns, what's the volume of data, the complexity of the data, how they want to run the system as well. And
mm,
so if it doesn't match up to our qualifiers, then we'll say, like, we're not a good match for you. And in some cases, we might say, you should talk to this vendor. They have a lot of experience with that. And going back to the trust building, that helps build
mm,
trust, right? Saying, hey, we're not a good fit for you right now. Right. And so that's sort of the beginning of it. As we start stepping into, like, if we're going to do a proof of concept with someone because we've never seen that data before, or they have different expectations, um, we outline things in such a way where we have checkpoints. So we have one going right now that's on a cloud we expect to work on that cloud, but we haven't run stuff on that cloud before. They have some very different types of query requirements. And so we're going through it sort of step by step. And so they had ingestion requirements. So we're
mm,
going to go through, we're going to do the ingest part of the proof of concept and make sure that we can tick that box. Yes, we did that.
mhm,
And then at that point, everybody agrees, like, do we move forward? What's the next step? If we meet that, then we'll go into the next piece. So all along the way, having really transparent communication with the customer about what we're doing, why we're doing it, how does it impact the overall solution, again, goes back to that trust building. So it's just you have to be so transparent the whole way through, and that can be really hard. It's hard to
mm,
say, "Can't do that,"
mm,
right? Like, you get to a requirement that maybe didn't come up ahead of time, but it's really critical to say, like, "We can't do that," is
mm,
hard to do, and so there's, some nuance to having the conversation, and it goes back to, "Tell me why this is important." Let's discuss how this thing impacts your business. And if it is really important, we can't do it. We just say like we can't fulfill that requirement. That's not something that we do. But that helps later. So if you have an opportunity with them again later, you've already built some trust
Mm,
by having that transparent communication with them and being really open. Because to me, like there's solutions engineering works with sales, right?
mm,
Solutions engineering's role is to be the trusted advisor. We
right.
we are effectively the truth teller. Our professional reputations depend on us being good at solutioning. And especially if you stay in data, like I've worked with some of the same customers over a decade at different
Mm.
companies. And so part of that is really like your professional reputation and keeping like prioritizing that for yourself helps the company do the right things as well.
No, I think very, very interesting points, right? Like honesty definitely builds more trust than overselling, right? Right. Even though if it's like sometimes not the kind of things that your customer wants to hear, and but like that's sort of essential to build trust with them, right? And help both of you move forward in a positive direction, right? So I think it's been a great time, Catherine. I know we've just hitting the 40 minutes mark on discussing solutions engineering, right? And personally, it's a very close topic for me because I don't know if you remember, like my sibling works in the same domain, so I have some sort of understanding, and I keep like having these discussions with him. But yeah, I think personally, it's been a very interesting learning journey for me to know more about Super Bowl and like what really happens when people are streaming data, and like and what's behind the scenes, right? Like what's and
Mhm.
this is like true behind the scenes. Like nobody is like thinking of these kind of things. There's actually a team sitting and making sure that your stream doesn't fall off, and you don't get like blurry video and all of that, right? So that's a massive job, and kudos to you and your team for doing that.
It was scary and fun.
Yeah. So let me move on to the last section of the episode, of the lightning round. So I'm going to ask, I know I've asked you like tons of questions already, but like three more, and not really about the topic like that we've been discussing, but just
Mhm.
in general, right? Like, so let's get started with the first one, right? So what's the one thing, Catherine, that has helped you shorten your learning curve?
Um, Honestly, it's just getting hands-on with something really quickly, and not being afraid of breaking things. So, if there's something that I need to know for a customer given a situation, I will, like, spin it up, install it, whatever it needs to happen, and just start working with it immediately,
Hmm.
because then you see the rough edges. But it takes being fearless, um,
Hmm.
'cause a lot of people will say like, "Oh, I might break it." It's like, you can't be afraid of breaking it. Like,
Hmm.
make a dedicated environment where you can break it all day long because that's actually where you learn the most is
Hmm.
when you break something, right? If I go through a course online and I didn't struggle with anything, I don't necessarily feel like I learned anything.
Hmm.
Like I went through the happy path, I followed the instructions, everything works, but until something breaks, you're not really for me, I don't really learn until I've broken it and I have to fix it.
Yeah. I think, yeah, like practical is more important than theory. And as you and do more practicals, like more experimentation, I'm sure like things would go south and they would break, right? That's given.
Right.
On to the next one, right? So what's something about your work now that you wish you would have known when you first started?
Hmm. I think understanding how other people think about their data better.
Mm,
And that comes through experience, but, like, when I went to school, I focused in object-oriented databases. This was years ago, and I thought they were really cool. I really liked object-oriented programming. It's, like, awesome. I can represent my data the way it looks in the real world, but that came with its own set of problems. It's like there weren't tools built around that, reporting and everything. but people still like there's thinking about data in terms of how you store and access it and thinking about data in terms of how it looks in the real world. And like understanding how to bridge those things better, I
Um,
think would have helped me
um,
more because sometimes like you get some really complex data and it's really hard to query. It's like, well, why did they do it like this? And it's because they were representing something as it was in the real world. So being able to identify that quickly and also understand the
mm,
why behind it more quickly, I think would matter very specifically in the data space.
mm,
I think for a second thing would just be for solutions engineering, how do you build trust and rapport with a customer quickly?
mm,
So, like, I think especially, a lot of solutions engineering, there's no degree in solutions engineering, right?
right.
We
Mm,
all ended up getting into it because we were in consulting or engineering and we were good at speaking to customers. So there
mm,
wasn't like a training kit that came along with like, how do you do solutions
mhm,
engineering? And, I'm honest to a fault even in my personal life, so that the honesty part was easy, but it's like the trust and rapport part is really an art. Like, how do you
mm,
build that in a way that during a Super Bowl event, the customer trusts you enough to say like, "Hey, can you go figure this out for me? I need an answer on this
mm,
right now."
mm. Makes sense. Very, very interesting. And the third and last one, right? Like I know we haven't touched on this topic or this particular keyword in the entire episode anywhere, but what's some of the like or maybe what's one AI tool that you're using right now and that you'll the most.
Yeah. We are using Claude
Mm,
internally quite a bit and Claude Code.
mm,
And, like, in my own personal experimentation, Claude seems to be the best with, like, technical stuff,
mm,
better than the other models in my experience so far. I think that, like, it's like the ChatGPT query that I mentioned that someone
right.
sent, like, it was overly complex. Like, there was this one line that
Mm,
had all this calculation in it that effectively could have been, like, that long.
mm,
And so, we're still learning where the trust lines are there. We have an internal tool that we're using that can, like, go through and look at Slack and Salesforce and Google Drive and all of that. And I think what we've learned pretty quickly with that is it it's like, I asked a question recently about one of our customers, and it came back with everything that we had said that wasn't necessarily, like, what I needed, but it was
mm.
all the stuff that had been said. So it was great at pulling everything that was said together, not necessarily answering my question. But yeah, all those things are powered by Claude. So that's the main one that we're using internally.
Nice, nice. Yeah, I think personally I use Claude and Gemini both. I keep shifting, but yeah, Claude is definitely more, suitable for technical and coding kind of prompts, right? So,
There
very.
was, we used so the just a real quick Super Bowl story.
Mhm,
So I mentioned our SRE team and some other folks were on a Zoom call with me all day. I was
mhm.
actually Google Meet. So Gemini was taking notes and recording. We had it on for like 8 hours though.
Oh, crazy.
And so we were like, "Okay, well, how's this gonna look?" Because, like,
Mm,
you test it with, like, 30-minute or hour-long meetings, what's this gonna look like? And so there's a one of the blog posts had something like, 98 lines per chicken wing or something like that, that came out of Gemini because we were talking about how many log lines we were getting every second, and somebody said something about how many chicken wings are eaten during the Super Bowl every year, like, they had read an article or seen some statistic on that. So Gemini actually came back and was like took, the number and calculated rows per chicken wing in the transcript, so it was pretty funny.
crazy.
But it's, there's we use Gemini, actually for all of our Google stuff internally, so meeting notes and things like that, and it's, pretty funny sometimes what it'll come back with.
Nice, nice. But yeah, like I think good to know that it would also transcribe 8 hours worth of long conversations, right? Like that's something I didn't know, but I'm sure like many people didn't know and maybe haven't tried. But I think good to share it out in the open.
Yeah.
Nice. All right. Great, Catherine. I think it's been a wonderful time having you on the show and having you share all these amazing moments from Super Bowl, especially, and also like other hydraulics customers on how you make sure that nothing goes wrong, whether it's like a 1 day event, a few hours long event, year long event that with like spikes at different days or different weeks, different months, or also like week long events as well. But yeah, thanks a lot for taking time and sharing all this great information.
Yeah, of course. Thank you.